Astronomer. It is the first Ask an Astronomer of spring. The equinox happened on Monday, and as always, we're going to talk all about it on this edition of Ask an Astronomer with our astronomer, Marley Leacock. Hey, Marley, how's it going? Happy spring.
Happy spring. I am so excited for it to be 15 degrees Celsius. Always so great.
Yeah, it is a bit rainy here on the unceded territory of the Musqueam, Squamish, Tsleil-Waututh, but it has been fairly okay weather. It's not freezing as it was a few weeks ago, but excited to get into our theme today. Also, happy Nowruz for everyone out there. We had a Nowruz event last Saturday. It was super exciting. Lots of learning on my part. We had dancers in the planetarium, and we had a few astronomers talking with us and in that event. But if you're out there on YouTube land or Facebook land, you can ask any question under the universe, and we're here for the next 30 minutes to answer your questions. Today's show's theme is the equinox. So Marley, why don't you get us into this? Equinox, equilux, what is all these terms that we talk about?
As always in astronomy, the terms are kind of like, kind of iffy. It comes a lot of the time, what we're talking about. So spring equinox, yeah, specifically the spring one, because there are 2 a year. We do get 2 of those. But I wanted to quickly start off with the astronaut announcement, a reminder that we'll figure out, or they'll tell us who the astronaut will be, the Canadian astronaut and the other 3 American astronauts, who they will be for the Artemis 2 mission. Now, of course, being on the West Coast, this means it's at 8 a.m. Because East Coast privilege, I don't know, like everything is always at a nice time for them and very early for us. But 8 a.m. Pacific time, it'll be broadcasted live on like NASA's app, but also on NASA TV, their live channel will be the broadcasting. So that'll be very exciting. I don't know. I'll probably get here early so I can tune in and watch it happen at 8 a.m., honestly, just to see what goes down. Otherwise, I'm on the bus, and it'll be really weird if I start to cheer on the TransLink bus.
Right. So just as a reminder for everyone, we've got 4 Canadian astronauts. One of them has already been to the space station, David St-Jacques. And then we've got Jeremy Hansen, Jeremy Seide, Joshua Kutrick. One of them is going to be announced to go on the Artemis 2 mission, along with, is it 3 other American astronauts?
3 other astronauts. They're all going to be American. Yeah.
Okay. And this is scheduled to launch around when?
November 2024, but they have to train so far in advance. There's a lot that goes into it. We'll probably hear a lot about it, I'm sure. It's pretty intense. They're all qualified. I'm excited. I don't know. It'll be cool. I'm excited to know. I've been waiting a long time, like everybody else.
If you're out there watching, let us know who you think the astronaut is going to get picked for Artemis 2. And of course, we'll probably talk about it on the next Astronomer, because that's going to happen before the next show on April the 6th. So tune in for that and hear Marley's excitement or disappointment. I don't know.
I don't think I'll be disappointed regardless of who's chosen. Like, I think I'll be excited. Like, who cares? Like, a Canadian gets to the first time, like whoever's picked will be the first Canadian to go like even that far into space, like for the first time. In fact, I think it's like the first non-American to go around the moon. Like, so first Canadian, first non-American. Like, it's a huge deal. It's a big first for whichever astronaut it is. So I'm excited whoever gets it.
Awesome. Super exciting. So on Monday, we had the day that we call equinox, which we commonly associate with the beginning of spring. Well, of course, this equinox, we have another equinox in September. The vernal equinox is what we call this one. But when we say these terms, Marley, what are we actually talking about?
Yeah. So in astronomy, terms are either or they're like pretty specific. Like, it kind of depends. Words have a very specific meaning. So I've heard equinox been described as lots of things, like the time when there's an equal amount of day and night, or you have no noontime shadow, or like this weird myth that it's easier to balance objects. So that's like not necessarily what an equinox is, right? That those 3 things, not really. Having no noontime shadow, that would happen only if you're at the equator. You would not have a noontime shadow. Every other latitude, you will still have a shadow at noon. So it's kind of, there's a specific meaning behind that word that's not necessarily any of these things. In astronomy, specifically the spring equinox or equinox is the exact moment the sun crosses the celestial equator, and in the case of the spring equinox, from south to north. So we have to define terms within a term, which is also very common in astronomy. So the celestial equator would be just if I took the equator on Earth and then blew it out into space, right? So this is what this diagram is showing. Our equator on Earth runs through here, and it's just been pushed out. Like, as if there's a giant sphere around Earth, we call it the celestial sphere. And so the celestial equator is that moment, that marker that we're talking about. And it kind of comes to like, how do we measure this? And what I really wanted to point and kind of dig into is this idea that equinox is equal day, equal night, right? It's kind of explained that way a lot of the time. All around the world will have pretty much close to the same hour of daylight and the same amount of nighttime, but it won't exactly be 12 hours of each. That's not how we measure the sun. Okay. So what's happening is the subsolar point is how we measure an equinox. The subsolar point is the spot on Earth's surface directly beneath the sun. And that point will move slowly along a north-south axis as Earth orbits the sun. The part where the exact point directly beneath the sun, where it's shining, will move, north to south and back down again as Earth goes around. During the March equinox, it's coming from the south. It crosses the celestial equator and moves north. Its most northern point will be during the summer solstice. Then it'll start to move back south again, crossing the celestial equator again, giving us our autumn equinox. And then its most southern point will be during December solstice. And day and night end up being close to equal, but not exactly equal. And it has to do with how we measure what the subsolar point is and how we measure the sun. So a subsolar point is an area on the surface of Earth where the sun's rays are exactly perpendicular. But when we think about the sun's rays shining on Earth, they're coming at all directions, right? So if this is our Earth and this is our sun, all of its rays are coming from all directions. So which ray do we decide marks the subsolar point, right? The sun is huge. It has a lot of light coming from it. Yeah. So which beam are we going to pick, right? It ends up, we now think of the sun instead of this big, globe. We think of the very central point of the sun, right? So that very central point, its light, where it hits perpendicular to the Earth's surface, or like a right angle, is where that subsolar point is. That's what we decide a subsolar point is. So on these days, like if you were to measure only the subsolar point, it would be 12 hours, right? It would be 12 hours a day, 12 hours a night, but we don't measure time like that. So now I get to ask Michael a question, for me, like, when does day start for you?
Well, day usually starts around 8:45 when I clock in here at the Space Center, but it doesn't actually start, Marley, until I've had my coffee, and you probably know that.
I do. I don't talk to you until you've had your coffee.
Okay, so when does the day start? Well, I would say when the sky turns blue, so we're now getting sunlight into the atmosphere, and so the sun is rising. You may not see it because there might be some buildings in the way, but if we were clear, sort of like horizons, it would be the point when the sun is rising over the horizon. And that's just me going off the top of my head.
No, that is exactly when we measure daytime to begin, right? So daylight begins the moment the first part of the sun comes above the horizon. And we measure sunset as the moment when the sun disappears, that last bit of the sun disappears. So what's happening now when we measure day and night is we're not thinking of the sun as that central point anymore. We're thinking of it as a large disk, right? Because it appears as a large disk in our sky. That's how we measure those things. And so the measurement of disk versus the point of the central point, that's what creates that few extra minutes of daylight on the date of equinox at most latitudes, right? So I think on equinox, the length of the day was like 12 hours and 12 minutes or something like that, right? So it wasn't a full 12 hours of day, and it was not a full 12 hours of night. When you have exactly 12 hours of day and exactly 12 hours a night, or the same amount of day and night, that's an entirely separate thing called equilux, which is entirely different. Equal day and equal night. So this is me having fun with shapes to try to show what I'm talking about. So our sun, and then the central point, which is exaggerated so you can see it in reality, it'd be like a tiny point. Yeah. When the sun sets during equinox, right here, that central point has set, but we still see the sunlight. There's still daytime, right? Yeah. So it's not that 12 hours. That whole thing has to set. That central point is already below the horizon, but the sun hasn't completely disappeared. So we would not consider that the beginning of nighttime. Okay. They're just two different events. When equinox not necessarily have the 12 hours of day, 12 hours a night that equilux does. So to compare and contrast the two, equinox, the sun we measure as a point, right? That subsolar point is coming from, the very central point of the sun, its light. It's a global event. The whole world, will experience equinox, and it happens twice a year. For us, it was Monday, March 20th, 2023 at 2 12:24 p.m. Pacific Daylight Time, because it's the exact moment that subsolar point moves over the equator. Equilux, we measure the sun as a disk. It depends heavily on latitude, and it happens twice a year. So even this year, Equilux happened on Saturday, March 18th, so a couple of days before Equinox. They don't necessarily happen on the same day. Equilux can occur several days or weeks before or after an equinox. So it's like kind of in the same time, but not necessarily that close. And we had a 12-hour, 2-minute, 32-second day here in Vancouver. That's the amount of time the sun was up from the first bit of it peeking over the horizon to the last bit disappearing. In 2025, that's like as far as I looked ahead. No, I looked at 2026, but in the next few years, the closest we get to exactly a 12-hour day is 12 hours, 0 minutes, and 45 seconds. So we never actually hit that 12:00 at all. And on the equator, you'll never have an equilux. You just won't have one, which is, I don't know, pretty neat. It depends where you are on the globe, which is very cool.
Well, if you're also on the equator, you're not really getting seasons either, right?
Yeah, I mean, yeah, that's
Like, do they even celebrate, like these transitions from winter to fall? Because it's all kind of the same, right?
Yeah, I think like my family's from the Caribbean, and it's instead of it being like a marker of like, oh, it's snowing now, it's just like, hey, it's a bit rainier than normal, like it's just like a slight change. They're not right on the equator, but they're pretty close, like where my family's from. So it is just like oh, it's raining now, it's rainy season, and then but it's still hot. Like it's still warm. But
well, what I find interesting is that, of course, in many cultures, the vernal equinox is actually very important. And of course, when we just celebrated Nowruz, that is their new year. And a large part of that is renewal, the beginning, but also because the sun was rising over a certain part of like the mountain range, in the Middle East. So my question is there a point, like during equinox, is it like due east? Is that when equinox happens?
Oh, yeah, the sun does appear to rise exactly due. Does rise in the east? I gotta remember the Wiggles song. That's the only way I remember it. So, yeah, it'll rise due. The Wiggles. Did you never watch the Wiggles?
No.
Wow. Someone educate Michael real quick. I don't know who that is. Generational divide. No, it will rise like due east and set due west, like during an equinox, or as close as it'll get to being due of each of them. That is a marker of equinox. The other thing is that, in effect, like it isn't exactly a 12-hour day, right? Like, because we're getting into like minutes and seconds of timings when it comes to equinox days. So in effect, to people who didn't have the ability to like measure down to the second, those like old, ancient times astronomers, right? Before we had telescopes, watches, and ways to like get that exact down to the millisecond and stuff. It essentially was exactly a 12-hour day. And you would notice it. Like, you can go on timeanddate.com and look at like the sun chart for your city, and it'll show you your length of day and the difference in length of day from the previous day. Yeah. And so like for the next few days, we get an extra 3 minutes and 40 seconds of sunlight, like every day. And that will add up, right? By the time we hit, the end of March, beginning of April, comparing it to February, it's a huge change. So it would have been measurable, just on a larger time scale than me telling you like, oh, we had a 12-hour, 2-minute, 32-second day. Like it effectively was that time. And so the point of measuring, like, and it being celebrated, all around the world and different cultures, also ties in, to the seasons and the changing of that, right? It was a measurable thing. It happens every single year. The same thing happens every year. It gets warmer, the days start to get longer, and of course you have, migrating animals and birds and things. And so it is really like a sign of, like, I don't know, like it is interpreted as like rebirth and regeneration and stuff, as things that have died are now coming back, right? So it's like all around the world for a reason, I think, because the whole world experiences it.
Yeah, no, and it is very special. It is actually something to celebrate. And I actually have, personal traditions where I like to give gifts on Equinox because it is sort of like that. Okay, your Equinox gift is coming in the mail.
Oh, excellent.
But it does mean something. I like celebrating something that actually does feel like there is change happening. We see it, here in the park. We've got those darn geese that are back again, and they're laying eggs. And there's a whole bunch of families that are just outside of our Star Theater that were all enamored with the 2 geese that laid an egg just on our ledge out here. So you can certainly feel it. It's in the park, and there's lots of change happening everywhere until we get to the solstice, which is, not too far away.
Yeah, devastating. I wish it was a bit further. Honestly, I could use a bit more summer. But when we had our Nowruz event, what I really like what I did not know was that Nowruz is also celebrated like at a specific time, like
Yeah.
it down to the second. So there were, astronomers, like Persian, Iranian, or that area that were able to measure it down that accurately, and get down to the minute to the second of exactly when they would be that moment Nowruz begins and is celebrate like the celebratory event begins. Because from what I understand, it was like a weeks long event as well. Like it's not just the one day, but there is an exact moment when the celebration like kind of starts, right? Which is exactly what happens with Equinox. I did not realize that was like the crossover was involved there. That Equinox is also at a specific time, and so was like Nowruz is at a specific time, which I really enjoyed learning. It's like, okay, cool.
Yeah, absolutely. Got a question in from Harry. Is the moon's gravity, or vice versa, pull in the long term eventually causing the Earth's daily clock to increase to a 25th hour? I've never heard that before, but
Yeah.
How is the moon potentially causing, I guess he's saying, a longer day?
Yeah, so how's it affecting Earth like rotation
Yeah.
on its axis? The moon does provide a stabilizing force to Earth, right? It's why we don't like oscillate extremely on our axis. The moon helps kind of hold us in place. So without the moon, our seasons would probably be very weird. I think to some extent it's producing a drag effect on Earth, I guess you could say, but I don't know exactly by how much or how we could round that up. The last cool moon fact I heard was that the European Space Agency wants to establish a time zone, a lunar time
Yeah.
zone, which I was like, please do not do that. Please just use UTC time like everybody else. But I don't know too much about the rounding getting a 25th hour day. I don't know about that.
Yeah, no, that is really interesting. I did hear about that as well. And of course, when we did go to UTC, like that was really important, especially when it comes to satellites, right? Like satellites need to have a synchronized time. And I suppose what the European Space Agency is trying to do is trying to create a moon time that has like specific to all of the activity that's going to be happening around the moon. But I am a bit confused as to why they would do that and why they wouldn't just stick to the UTC
Yeah.
because it's been working well so far, right?
And working well so far. It's what the astronauts are used to, especially when they're in space. They're used to running on UTC time. So might be a better idea to keep it that way, which I don't know. I
Yeah.
just thought it was funny. It was like, because there's always, the arguments about why do we switch the clocks or whatever. And then the ESA was like, I would like to introduce a lunar time zone. And I was like, there's too many time changes happening already. Don't introduce another. Another fun fact about Equinox is that satellites are actually incredibly affected by it or can be
Okay.
because especially the geosynchronous satellites, they face like the full brunt of solar radiation, right? Because it's the one time when Earth is not tilted away or towards the sun during an equinox.
Yeah.
And so they get like the full amount of solar radiation on them, and it can cause like outages in satellites and stuff and be harmful to their hardware.
Oh, is that because like they mainly orbit around like the equatorial belt around the Earth?
Yeah, like the ones in specific orbits that are going around, or like geosynchronous, like the ones that
Yeah.
are over a specific part of Earth, like all the time, no matter what. During an equinox, they're like kind of right in that subsolar point.
Oh,
Yeah,
interesting.
yeah, they can be, and it can fry them. It's pretty bad. I didn't know that. I was like, oh, that makes sense though. They're right in the brunt of it, so that would do it.
Yeah, interesting. Pride has a question about like, is the year expanding? She heard that it might be expanding, but very small.
Oh yeah. So this is, I think, what this is, from what I remember, is like how we tell time is like weird. Um, and it's based like watches are like quartz vibrating at a specific frequency, and that's what gives us a second. Like it's really actually extraordinarily complicated. And so they find that maybe their measurements of the second are not exactly, and that the year may actually be like a millisecond longer. Like there was like, do we add a leap millisecond to account for something or the other?
Right.
When it's that small, I don't like, okay. Yeah, but it's weird. Like keeping time was a lot easier when we did not have so many cool tech stuff, I think. Like when we were just looking at the sun
Yeah.
and watching the sun rise and set, there's a very distinct limit. The sun is there, the sun is gone. Now it's dark, it's night. And now that we've introduced like how we measure seconds and timekeeping and atomic clocks versus other clocks, like it is very, yeah. And our desire to make everything into base units and defined off of one big unit is also like annoying, but can also influence that a lot as well.
Yeah, back when you just told time by high noon, we're going to meet out and
Yeah.
duel at high noon.
Yeah, exactly. That was great timekeeping. Why did we change?
I wonder if that was because there was no shadows. So maybe the shadows
No,
were
there would only
obscured.
be a shadow if you were like specifically the sun was directly over top of you, right? And because the earth is tilted, you'd have to be exactly in that subsolar point, right? So ah, I think there still would have been a shadow. It just would have been the shortest shadow you would have seen at
Okay.
high noon. Yeah. Depends
I
where you
always,
are on Earth. Yeah.
yeah, I always wonder like why they picked that time for the duel, or that was just maybe that's just a myth and
It's
movie.
lunchtime. Everyone needs a break. Time to go watch some dudes fight.
Awesome. Well, if you are out there watching on YouTube land, of course, you can ask some questions about Equinox, Equilux. We do have one more story, though, for you. And of course, we're talking about the sun. We're talking about a planet that is going to be visited by a few missions soonish. There is one that's kind of in flux right now, but
Mhm.
we have some new data from what's going on the planet Venus.
Yes, this was actually very exciting. And I say that as someone who like is not often excited about planetary stuff, but this was very cool. We have for the first time, scientists have seen direct evidence of active volcanism on Venus. So
Wow.
Venus is often described as like the volcano planet. It's got, tons of
Yeah.
volcanoes spewing. We had never actually seen direct evidence of it. We had assumed based on a lot of other data that there was probably active volcanoes on the surface, but we never had direct evidence of it. And so this is the first time that we have that direct evidence. The scientists looked at archival radar images of Venus taken from over 30 years ago by the Magellan mission. So shout out to archival data. And they saw a volcanic vent changing shape and increasing in size in less than a year. So the scientist, Dr. Robert Herrick, is credited for these images. He manually compared images. So like image A, image B, stared back and forth, which is a very like old school way of doing things. And two images of the same region. That's what A is and B are up here. They're in the Matmons region, which is like an area of like volcanic activity. We assume so. Like two volcanoes, Ozymandias is also there, but we're focusing on this area. Picture A was taken February 1991, and picture B was taken October 1991. And this region was thought to be long thought to be volcanically active, but there had been no direct evidence of activity until Dr. Robert Herrick went kind of combing through data. In A, what we're looking at is this vent here. So the vent is like the top of the volcano where stuff comes out. We're looking at A here, or the vent here. It looks, very circular. It's covering less than 2.2 square kilometers. This is radar data, which tells you kind of like the height of things. And so from this, it's pretty, deep, like steep interior sides and like signs of drained lava, like lava that is drained out down below, like flowed down. It slopes. And in B, we look at it. This is now in October 1991 when this image was taken. And the same vent has now like deformed and expanded. So it's much larger, it's deformed, and it looks deeper, right? Like it looks like it's filled with something inside, filled to the rim. They think with a lake of lava is now sitting in the bottom. And then we have this interesting feature here where they think is like new possible lava flows where lava has flowed down. And this vent like did not change. But it's hard to tell exactly what you're looking at, especially if like you don't know what radar imaging looks like. And also, even if you do know what radar imaging looks like, these were taken in two different directions. So this was pointing east, the beam came down pointing one way and took this bounce back up off the planet back to the satellite one way, and B was taken with the beam going the opposite way. So you get, it's a slightly different picture. It's the same area, but it just looks a little off, right? They're not perfect copies of each other. And so because of that, it makes it hard to compare what you're seeing. So Dr. Herrick consulted with Dr. Scott Hensley from the Jet Propulsion Laboratory, who is actually the project scientist for Project Veritas, which is a anticipated Venus mission. And he's kind of like a specialist in analyzing radar data, specifically like radar data like from the Magellan spacecraft. And the two of them together created all these different computer models of the vent in various configurations to test different geological scenarios. So trying to see if anything else could have possibly caused this, right? We don't want to be like, it's a volcano. We're not going to look at any other possibilities. You want to go through and check, could it have been something else? Rule out everything before you say it's this one thing. And from doing that, they concluded, like all their modeling, that only an eruption could have caused the change that they see. And, to put it in context, it is only one data point of direct volcanic evidence for the whole planet, but it's a pretty important and pretty interesting data point. And it does confirm that there is modern geological activity happening on Venus, which we kind of hoped and probably thought that there was, but we know. And so it sets up these anticipated Venus missions with like a lot more that they could look at and study.
Yeah, that's really interesting. I mean, the common thought, I thought was that Venus used to be volcanically active, and then maybe it like stopped, or maybe they were still, but we certainly didn't have any evidence of that. But now, this really kind of like changes the focus, and of course gets us really excited for those future Venus missions that are all going to the planet, right?
Yeah, no, it's very exciting, especially for like Project Veritas. That'll be very cool, I think it also has a radar. It's been so long since I actually looked at that one. I remember looking at them a lot when they were like announced, but now it's been a while. But regardless, the Venus missions, like it's just an added thing they can look at and study. Like so much of studying, especially the inner planets, but all planets, but really the inner ones, is we're all kind of very similar. Like the inner planets are all rocky, Venus and Earth roughly the same size, Venus a bit, bit different. But it helps us you kind of piece together what was happening in our solar system and what happens during planetary formation, because we kind of know how Earth worked a bit, but it's a lot of guesswork, and that we pull the guessing from all the other planetary bodies nearby. So the moon, Venus, Mars, like studying all of the Mercury will help us learn about what exactly was going on in our early solar system and how these planetary systems form and develop over time.
Very cool. Yeah, we did a whole series on Venus. Was it last year? Was it?
I think it was April. I think it was almost a year ago. Yeah.
Almost a year ago. Yeah. And of course, when those new missions start to go, we'll certainly be diving back into Venus again. So super exciting. Of course, next month, we are going to be focusing on galaxies. So that's next month's theme. April, Marley, you're going to have a brand new blog that's going to be going up on our website. Hopefully everyone out there reads the monthly blog, and galaxies is going to be the focus of a bunch of different events we're going to do. We're going to do another listening room, which is our second iteration of that project, all music, all galaxy images. That's going to be on April 15th. And then we're doing another Cosmic Night, which is going to be super exciting. We've got Dr. Riley Hill from UBC that is going to be taking us into some of that JWST data about the earliest galaxies in the universe. So really, really exciting stuff. That is going to be on April 27th. So that's coming up. And of course, I'm not going to be here for the next two Ask an Astronomers. I know, Marley, you're going to be very upset.
My grandma's going to be really upset. Be devastated.
But we've got great replacements. We're going to have our head interpreter, Matthew, as well as our digital producer, Millie, that are going to fill this seat very admirably. We have one final question before we end on today's show. Back to Harry. Mercury and Venus without moons, so other planets, including ours, is it definitive that moon would have originated from a host planet?
Oh, yeah. So the giant, what is the name of this theory? The giant impactor theory. I always mess it up, but when something hit us, that is the best that we have right now. So that is the leading theory of how our moon formed, was that this Mars body Theia crashed into us. Mars-sized body Theia crashed into us. It was destroyed in the collision. Part of us was kind of sloughed off during the collision. The debris formed our moon is kind of the leading theory of how we got our moon. There's still like some questions in that theory, particularly around like it would have to be pretty specific. That's one of the big criticisms of it, is that they would have to hit Earth at just the right speed, at just the right time, at just the right angle to make sure that we were not also like eradicated by that collision. So it is very specific, but that's part of what the Artemis program is trying to figure out. That's like one of the scientific reasons of going back to the moon, is now that our technology has increased so much, we're able to just kind of collect more samples and do more in-depth analysis on those samples, which can help us uncover exactly what the moon is made of. We kind of know what it is made of, but just like better information, more accurate information, more in-depth information, which helps us go back and refine theories as well. And looking for water on the moon is also part of that, because where did the moon get its water, right? Like, did that start when Earth was hit? Maybe not. Like, Earth is supposed to be cooling at that time. Like, there's just a lot of questions that scientists still want to answer, but that theory is still the leading theory, because the other two we had just don't work. You're muted, Michael. But while he's muted, real quick, if you wanted to read this paper about volcanic activity on Venus, this one is public access. It was published in the journal Science. I'm pretty sure it is public access. You can go find it and read it if that's something you like to do.
There you go. That is today's Ask an Astronomer. Like I said, I am going to be away for the next month, the next 2 episodes, although the next episode is going to be on April the 6th. Marley's going to be talking about Juice to Jupiter. That's going to be pretty fun. Our digital producer, Millie, is going to be there. In 2 weeks after that, on April 20th is Earth Day focused. And then 2 weeks after that, it's May the 4th. So you know what we're going to be talking about then. Marley and I, of course, super Star Wars nerds. We're going to hopefully be delving into some sci-fi, maybe even reaching out to someone locally. Stay tuned for that. But for everyone out there, happy spring, happy equinox. We will see you all again in 2 weeks. Take care, everyone.
Well, I'll see you. Michael will see you in 3.
That's right.